Hi everyone, this is the gas walkthrough for May 18th. I'm Philip Newman. Today I'm solving Waterboy by Bill Murphy. This is a consecutive pairs puzzle. Normal Sudoku rules, 1 to 9 in each row, column, and 3x3 box. Additionally, we have some white dots in the grid, and these dots mean that the digits in the cells are consecutive. They have a difference of 1. There is no negative constraint, so these two cells, for example, could also be consecutive. We just don't know. And those are the rules. Pretty straightforward. So let's start up here. 1 can only go next to 2, and now the 2, since there's 1 here, must go next to 3. 3 can't go next to 2 because it's already in the box, so this is 4, 5. 5 can't go next to 4, so this is 6, 7. These are going to be 1, 8, and 9. 9 down here needs 8, 7. The 7 now needs to be 6, 5, and the 5 needs to be 4, 3. And these are going to be 1, 2, 9. Some symmetry sort of here, but these are in a different order, so it's not going to be totally symmetric rotationally. Let's illuminate these. And we need a 3 somewhere over here. It can't go here. I don't know if this is really the best place to look. I do see something else, but I spotted it. So 3 must go in one of these two cells, but it can't go here because either we have 3, 4, 5, which breaks, or we have 3, 2, 1, which breaks. So the 3 must go here. Maybe we can do something similar over here with the 7s. 7 has to go in one of these cells. This can't be 7, 6, 5 because of the 6 here, and it can't be 7, 8, 9, so 7 must go there. Alright, let's return to the other thing I spotted. One thing with consecutive pairs is because they have a difference of 1, one of the digits must be even and one must be odd. And you can use that quite often when you have most of the even or odd digits in a row, column, or box. It's going to narrow down what can go in the dot. So we already have 2, 4, 6 in this column. The even digit must be 8. And we already have a 7 down here now, so this must be 8, 9. Here we have 4, 6, and 8, so our even digit is 2. We have a 3 here, so this must be 1, 2. Now let's look at the rest of these columns. We need 5, 7, 9 here. I don't think these are resolved, but we'll go ahead and mark them. These are 1, 3, 5. That one's now 5. Alright, do we need to think about these dots now? Maybe we do. I didn't test solve this, so this is fresh to me. Let's talk a little more about the even and odd thing. There's probably something better to do here, but what caught my eye? Actually, I know there's something better to do. I'm going to talk about it anyway, just because I saw it. There is an odd digit in one of these cells, which means we have 4 odd digits here. So we can't have 2 more odd digits. The odd digit here must go in the middle with 2 even digits. And this can't be 1 or 9 because it can't go in the middle. So the only thing left is 7. And that's going to resolve all of that. The other thing I saw is 1, it can't go in these cells, and it couldn't go on this 1, 2, 3 breaks here. So it has to go on this dot. This is 1, 2. Around the 7 is 6 and 8, like that, and this is a 4. And now we can fill in the other possibilities here. These are 3, 4, 5. We have a 5, 9 in the column now, so that's 7. And then these are 6, 8, 9. I can type the right digits. Okay, down here, same sort of thing, I suspect. 9 can't go in these cells. It also can't go on this, because we need 9, 8, 7, which breaks. So it must be on this dot with the 8. And this must have a 3 or 4 on it. That's probably not the way to look at it. Let's look at odd digits. We're missing one odd digit, so again, it must go in the middle. It can't be 7 or 5. It also can't be 1 or 9, so it must be 3. That's going to resolve these. This must be 2, 4, and that's 6. 1, 2, 4 in the column, and 5, 6, 7. Alright, these dots are a little restricted. We still need an odd digit. It's either 7 or 9. So that means we have 6, 7, 7, 8, or 8, 9. This is not 7, so this is not 6. Here we need a 1 or a 3 as our odd digit. So 1, 2, 2, 3, 3, 4. This is not 3, so this is not 4. Probably there's some cleanup we can do here. 7 must go in this cell. 9 must go in this cell. Now we just have our even digit left here. This is 8 in the row. These are 2, 4, 6, so 4 goes here, and this is 2, 6. That means this is not 4, which means there's a 2 in one of these cells. So this is, wow, I really can't type. 2, 1, 2. This is the other digit from 1 and 3 that's not on the dot. One thing you might notice here is a uniqueness technique. We don't ever actually use uniqueness in gas. I don't think we've done it at all. If we have, we've posted a big warning that that's the intended thing. But this could not be 3, because if it were, we would have no way of telling which way around the 1 and the 2 went in these cells. That's a uniqueness technique. Since we know it has a unique solution, we could eliminate the 3, but we won't assume that. It's just not how we solve. 3 in this box must go here. This is a 1 or a 2, and we have 1 there, so that's resolved. 2 in the row resolves 2 and 9. This is 9 and 8. These are 4, 8. And these are 1, 6, so that's going to be 1, 6 in that order. This is not 6, so we have an 8 here. And now this is the other odd digit from 7, 9. These are 4, 5, 6. We finish this pair. And now we are just left with the middle here, it looks like. This can't be 7, and this can't be 3. We do have a 1, 2 pair here, so that's going to make that 4, which makes that 5, 6, 7, 9, and 8. And we have an 8, 9 pair here, which makes this 6, 5, 4, 3, 1, 2. And that's going to finish everything else off. Let's fill in all those digits. 8, 9, 8, 7, and finally a 6 to finish it off. So that probably took me a little longer than it should have. Yeah, it was really enjoyable though. A lot of neat stuff that you can do with consecutive pairs with the odd-even thing, even though it almost certainly wasn't strictly necessary, but it was fun explaining that. Let us know how you did in the comments, whether you used any of that odd-even trickery or just found a more straightforward way through it. But I will see you next time.